Effective length is a fundamental concept in structural engineering, particularly in the design of compression members such as columns, braces, and some beams. It refers to the length of a structural component that is effectively free to buckle, considering the support and restraint conditions at its ends. The effective length plays a crucial part in determining the member's stability and its critical buckling load. Before we go into the effective length itself, we have to talk about end conditions. The ends of structural elements can be constructed with different end conditions. The options for these end conditions are fixed, restricted in position and rotation, pinned, restricted in position, roller, restricted in rotation, and free, no restrictions. Depending on the end conditions, structural elements are assigned an effective length factor K, according to the following table. Fixed to fixed gets an effective length factor of 0.50 with a recommended design effective length factor of 0.65. Fixed to pinned has values of 0.70 and 0.80. Fixed to roller 1.0 and 1.20. Fixed to free 2.0 and 2.10, pinned to pinned 1 for both of the values, and pinned to roller 2 for both of the values. These effective length factors and recommended values come from SkyCiv. A structural member's end conditions, whether fixed, pinned, roller, or free, directly affects its effective length and therefore its buckling capacity. The more restrained the ends, the shorter the effective length and the higher the buckling resistance. The effective length of a member is calculated as LE, which is K times L, where LE stands for the effective length of the member, K stands for the effective length factor determined by the end conditions of the member, and L stands for the unbraced length of the member. For a column that has an unbraced length of 3 meters and is fixed at both ends, this would give us 3 times 0.65, which equates to 1.95 meters of effective length. For slender beams, stability failures such as lateral torsional buckling, or LTB, can govern the design more than basic strength criteria. In these cases, the effective length is crucial, as it is used to calculate the slenderness ratio, a key parameter in stability checks. Design codes such as Eurocode 5, EN 1995-1-1, and others incorporate the effective length method or second order theory to ensure that structures are safely designed against buckling. Additionally, due to timber's inhomogeneous nature and sensitivity to defects known as the size effect, accurately assessing the effective length is essential for maintaining realistic safety margins. To ensure a safe and effective design, start by identifying the end conditions of your column. Then, determine the corresponding effective length factor K based on those conditions. Multiply this K value by the unbraced length of the column to obtain the effective length LE. Use this effective length in your buckling calculations to determine the critical load the column can safely support. Understanding and correctly applying these principles is vital for designing stable and efficient columns in any structure. If you enjoyed this video, take a look at this video, which YouTube thinks you'll like. Stay informed, stay inspired. TimberTalk.